Hello everyone, welcome back to another video for physics and math. This video is going to be about the explanation for definite integrals. Like I said, in my last video, I was going to do a video for the explanation, and yeah, this is it. Now, before we get into what definite integrals, like how they work, how they work, like yeah. First, we have to talk about two terms: geometric area and signed area over here. So, what is geometric and signed area? So, geometric area is just normal area, the area of any like physical area. So that's like the normal area you like the normal area term you use every day. But the signed area term, that's very different. And that is because it's like signed area is like it's the accumulation of yeah, it's because it's kind of like net area in a way. Like to help you understand what I mean by that, it's like imagine you have two vectors, right? One vector, like two vectors acting on an object. One vector is 5 meters per second positive, and the other is negative 5 meters per second. So those two vectors would cancel out, right? So the net vector would be 0 meters per second. In the same sense, that's how signed area works. So if I'm going from left to right, right? Like when we do this a definite integral, right? Like from if I were to do from -3 to 4, right? So since then I would start to like take seeing how much area accumulates. So I would take 4x delta x, 4x delta x, 4x delta x, right? But because it's like and that's like the area that accumulates, and from -3 to 0, and then from 0 to 4. And since from 0 to 4, that means like from 0 to 4 there must be more area, cause like more positive area, and from 0 to -3 there must be less negative. So the result will end up being positive. But if we were to do it the other way around, say like going from 4 to -3, it becomes reversed because every delta x we go is like negative. It's negative delta x. That's why we're going this way. So and it would become like negative 4x into delta x, right? And then the area would become, this area would become negative, and then this area would become positive. So it would actually become flipped, and that's basically how it works. So now that like that's how signed area works. Now let's talk about how like definite integrals relate to signed area and how they like generally work. So we have our example here, right? -3 to 4. Let me get the text. Or no, I just require the mouse. Okay, so we know the antiderivative of 4x into delta x is 2x squared, as we talked about in the last video. So 2x squared is the antiderivative. Now, in the last video, we know that we had to substitute the top number into 2x squared. So 2 into, and the top number is 4, since we're going from -3 to 4. So wait, let me quickly properly write the definite integral. This is gonna, yeah, okay. Just put that there and control, yep, and -3, yes. So from -3 to 4, we have so we would substitute in 4 squared. Oh wait, no. Okay. Oh no. Okay. Wait one sec. Technical difficulties. Yep, okay. Minus, wait, what? Okay, yeah. Minus -3 squared, which is, sorry, so 2, oh gosh, okay. -2 into -3 squared. Yeah, okay. So this would, Yeah, okay, yeah. Let's just keep it like that. Okay, so 2 into 4 squared, and 4 squared will become 16 times 2, which is 32. 32, right? And then you would negative 3 squared is 9 times negative 2, which is negative 18. So let me just quickly do negative and then bold 18. So yeah, 32 minus 18, which is equal to 14. That's our answer. Yeah, 14. So this would equal 14. That's the sign, the total accumulation. But like we said, when we go from the other way around, it becomes flipped. So let's try it this way. Let's flip it. Negative 3 and 4. So what do you think would happen now? Well, what would happen is that since we're now going from this way to this point to this point, the positive area is actually now less than the negative area. So the answer will become negative. And also, one rule that when you're doing definite integrals, one rule is that you should always first substitute in the top number for the antiderivative, and then substitute the bottom number for whatever antiderivative you're subtracting. So we do negative 3 squared. So 2 into negative 3 squared minus, wait, bold again. Okay. 2 into 4 squared. Okay, yeah. And this would equal to negative 3 squared, which is 9 times 2, 18. 18 minus 32. Okay, 18 minus 32 is negative 14. Like, yeah, negative 14. Now notice, the sign flipped. At first, when it was 4, when 4 was over here and negative 3 was there, it was 14. But now, since they flipped it, like we flipped it, now it's from it's from 4 to negative 3, and that made it negative. So this became negative 14. And that's kind of how that's how it works. Definite integrals, when you switch from what number you're going to starting from to what number you're going to, the sign flips. So the sign, yeah. So it's practically like multiplying it by negative 1. So yeah. Yeah. I think that's it. Thank you for watching, and I hope to see you guys next time in another video, cuz I really like making these videos for you guys. And I also encourage you guys to give me any kind of improvement I could do, cuz I really think I could have better analogies and stuff like that. Also, for upcoming videos, I'm going to also be trying to include some more physics, because these videos so far have just been about math. So yeah, I might do I might talk about certain aspects of physics, but the main aspect of physics I'll be covering in this YouTube channel, the main aspect I'm trying to lead up to is quantum mechanics and relativistic physics. So the physics that kind of govern our worlds, at the fundamental scale, those physics really interest me, and I hope to teach you guys and learn more about those fundamental physics. So yeah, see you in the next video. Thank you for watching, and bye.